Hello everyone, welcome to my presentation. In this session, I am going to explain about the types of spillways. The outline of my presentation is spillways and classifications. Spillways. What is the necessity for the spillway? The necessity of the spillway is to provide the safe passage for the floodwater downstream as to avoid the danger of the dam being overtopped. The part of the dam which discharges the flood flow to the downstream is called as a spillway. It is an internal part of the dam. The spillway must have the capacity to discharge major flood without the damage to the dam and other structures at a time to maintain some adequate maximum level of the water in the dam. The spillway is an important part of the dam complex which is located near the part of the dam or separately at the suitable place near the dam. The flow of the water over a spillway must be controlled by installing gates over the spillway crest. Such spillways are also called as controllable spillways in a modern days. The spillway acts as a safety valve for the dam. Spillways and the gates help in the passage of the flood water without any damage to the dam. They keep the reservoir level below the predominated maximum levels. There are three approaches components in that. First one is the major approach admits the flow of the spillway. The discharge conduit evaluates the flow from the approach facility to the outlet structure. The outlet structure dissipates the excessive energy of the flow from the discharging conduits and conveying tranquil flow to the downstream. Classifications of the spillways. Depending upon the location of the site, the following are the classifications of the spillways. Overflow spillway, chute spillway, side channel spillway, saddle spillway, Siphon spillway are the classifications. In that, first one is overflow spillway. This is the overflow spillway. The dead storage of the water level is 93.57 meters and the average level of the bed is 18 meters. The full reservoir tank is there and the top of the dam, that is the 146.5 meters is there. This is the gate. When the gates open, the crest level elevation is there. It is in the form of S shape. The over type of spillways is a simple in design and the low in cost, and it is suitable for concrete dams. An overflow spillway may also have a control device called as gate at the top of the crust, or it may be without any such control. For an ungated spillway, the crust level from the full reservoir level at the height and to the flood left added over the crust level corresponding to the maximum water level. However, when the spillway is gated, the gates provided an additional storage up to the crust top during of flood season. Thus, in such cases, the maximum water level coincides with the full water level maximum. This type of spillway is widely used on gravity arch and brittleness spillway. So, this is the full reservoir level and this is the maximum water level. If both are equal, then the water flow will occur. And second one is the chute spillway. Chute spillway are the common basic in design and are transferred axis water from behind the dam down a smooth decline into the river below. The spillway slope and its sides are lined with the concrete. In the case of having sufficient stiff foundation condition at the spillway's location, a chute spillway may be used instead of overflow spillways due to the economical consideration. Next is the sideway spillway, side channel spillways. It is employed when valley is too narrow in case of a solid gravity dams and when non-grid dams are adopted. The side channel spillway is different from the chute spillways in the sense that after crossing over the spillway crust, water flowing parallel to the crust length in the former, whereas the flow is normal to the crust in the latter. And next type of spillway is saddle spillway. There are nature decompositions, that is, depressors or saddles of the periphery of the reservoir basin away from the dam. The depressor may be used as a spillway. The bottom of the depressor should be at a full level reservoir. So this is the depressions or the saddles. This is the top of the dam. So when the saddles at the top of the dam must be coincide, then the free reservoir level occurs. Another classification is shaft spillway. In the shaft spillway, also known as morning glory spillways, has shape of vertical funnel with a vertical shaft which connects an L-shaped horizontal outlet conduct extending through the dam or through the abutment conveying water past the dam. Thus, a shaft spillway, the water from the reservoir enters into a vertical shaft which conveys this water into the horizontal tunnel which discharges the water into the river downstream. Another classification is Siphon Spillway. The basic principal operation of the Siphon Spillways is based on the Simpsonic action. There may be a natural depression or the saddle of the periphery occurs in the river basin away from the dam. The crust is created at the full reservoir level. So, at the full reservoir level, crust occurs. When the water level in the reservoir level overflows level, water starts spilling over the crust. A hard race of a channel which conducts the water to a turbine and the tail race in a channel which conducts the water from the wheels. There are two types of conducts, open conduct and closed conducts. And next element is surge tank. So in surge tanks or the tanks in a small reservoir which water level falls to reduce the pressure swing so that they are not transmitted to the closed conducts. They reduce the distance between the free water surface and turbine and thereby reducing water hammer effect. The change is in the pressure rapidly above or below the normal pressure causes the sudden changes in the rate of the water flow from the pipe according to the demand of the prime mover of the penstock. To serve the supply of the tank to the turbine in case of increasing local conditions and the storage tank in case of the local tank. So this is the surge tank. From the reservoir, the water is collected from the penstock before the surge tank, or else the back pressure or due to the back pressure of the turbine, the penstock will get damaged. So the water is stored in the surge tank. Functions of the surge tanks are: it reduces the distance between the free water level of the reservoir and the turbine, and also reduces the intensity of the water hammer. Thus, only relatively short length of the conduct before the surge tanks needs to be designed to withstand the water hammer effects. And the surge tanks acts as a relief valve when the demand load on the turbine is reduced and the pressure in the pipe suddenly increases by diverting the main conduct flow partially or wholly into the tank. The water level in the tank rises until it exceeds the level in the main reservoir, thus retaining the main conduct flow and absorbing the surplus of the kinetic energy. The tanks acts as a temporary reservoir which increases during the load of the turbine when provided sufficient water to enable the turbine to pick up the increased load quickly and safely until the water level in the surge tank falls below its original level. Sufficient head is thus available to accelerate the flow in the penstock until its sufficient is to meet the new need. Types of surge tanks. There are different types of the surge tank based on the material of the construction, concrete or steel, based on the location with respect to the ground, underground or overground, based on the location in the hydraulic system, whether it is the upstream side or downstream side of a powerhouse, based on the shape. This is the most common way of the classification: simple cylindrical surge tank and rectified orifice surge tank. Surge tank of the special design and differential surge tanks. So these are the four different shapes. In that, first one is simple cylindrical surge tank. These are the cylindrical in shapes and are provided between the penstocks and pressure tunnels. These are not so common these days. In rectifier orifice surge tank, this is the modifications of the simple cylindrical surge tank. In such tanks, an orifice is considerably small diameter than the surge tank diameter is installed between the surge tank and the conduct stream. When the load on the turbine drops and rejected, mass of the water enters into the surge tank through the restricted orifice and then bends up quickly, a retarding head in the conduct. Such tanks of special designs are of use. And differential surge tanks, these are the more efficient than simple surge tank. Has been an additional internal raised pipe provided with an angular ports connected to the chamber. Those angular ports open into the outer surge shaft. This interlinking raises up the surge shaft. When the load demand is higher and the water level in the internal river quickly, thus creating a large accelerating head of the conduct in a short time. The water falls slowly in the outer surge tank begins to be a larger tank and the water flows through the ports in the pipe rises and the vice versa. Here the penstocks are also known as the prime movers and the draft tubes are also used. Draft tubes are of two types, conical type and elbow type. In conical type, used on low powered units for all specific speeds and frequently of large head units and the side angle of 4 to 6 degree. In the elbow type, mostly used vertical portion in a conical section which reduces the flattened elbow section and thus discharges horizontally. So these are the different classifications of the surge tanks and spillways. In our next session, we'll discuss about the hydrological. What is meant by an hydrology and how the water levels are measured in the runoff by using the hydrographs.